Hello everybody, welcome to final exam review. I want to start by noting that this is in no way comprehensive. The final exam will be 25 questions and I've picked out a few that typically give students trouble. So we will cover 8 or 9 questions as part of these videos, but it is not comprehensive. I will mention topics as we go through so that you can make sure that you prepare for other topics as well. So what I wanted to start with this morning or this evening whenever you're watching it is something like graphing a piecewise function. So you will have to graph a piecewise function for the final exam. So something like f of x is equal to negative x plus 3 and 2x minus 3. For x values less than 2 for this top one, and for x values greater than or equal to 2 for the bottom one. Now remember that first this is number 5A. I'm picking problems from the review, not problems that we went over in the lab mostly, but some problems from the review itself, so I'll number them as we go along. This first one, remember, piecewise function means that it does something different over parts of its domain. So for this function, the first thing I'm looking at is where does the function actually change from one function to another. So if I were to consider that first, I'm looking at this piece. So at positive 2, it's going to change from that top function to the bottom function. So I personally like to put in something like an asymptote line so that it reminds me later on to switch, and here is where I'm going to do that. Not actually part of the graph, just helps you with visualization. Next part is to make sure that I know what functions those are. So this first one, negative x plus 3, is a line. Got a negative slope, so I should expect it to look something like that. And it's over in this region, so I should expect something over here. For the other one, it's a line too, has a positive slope this time, so I should expect something like this on this side. Now, as far as open and closed circles, the top one has an open circle because it's strictly less than. Bottom one has a closed circle because it's greater than or equal to. All right, looking at, wow, this calculator has got a tight thing. All right, looking at the functions themselves, if I were to plug in 2 in the first function, f of 2 is negative 2 plus 3 gives me 1. Now that's going to be an open circle because we've got strictly less than. So here I have an open circle at the point 2 and 1. So there's our point. Now I can just count the slope for this line. So this is a slope of negative 1, which means that I would go up 1 over 1 to get to the next point, up 1 over 1 to get to the next point, and so on. So I've got a line that looks something like this. Now on the other side, if I plug in 2, I get 2 times 2 is 4 minus 3 gives me negative 1. So I have a point at the point 2, negative 1, and this line has a closed circle and a slope of 2. So if I count up 2 over 1, up 2 over 1 to my next points. And it looks like this. When you're done, make sure your piecewise function is actually a function. It should pass your vertical line test when you're complete. The next thing I wanted to go over is a quadratic function, so analyzing a quadratic. You will have to take a look at a quadratic during the exam. So I'm just picking one of these at random. So number 7C, for example, says h of x is equal to negative 3x squared plus 3x minus 2. All right, it asks for a bunch of things. First thing is it asks for is the vertex and the domain and range and axis of symmetry and intercept points, and then it asks you to graph it. So you are going to have to do all of those things. I'm going to put a graph over here. just because as we complete finding these things, then we'll use the graph itself and plot it on there. All right, so first piece is the vertex. Vertex-wise, you can either remember the vertex formula, or you can use the completing the square option and put it in standard form. So if you're going to use the vertex formula, then x is equal to negative b over 2a. So I have negative 3 over 2 times negative 3, or 1/2 for my vertex, for my x coordinate. For my y component, then, oh, it's an h, not an f. Then I have h of 1/2. I wrote an f again. I really like my function notation as f's and not h's, but that's okay. So h of 1/2, and it gives me negative 3 times 1/2 squared plus 3 times 1/2 minus 2. Negative 3 times 1/4 gives me negative 3 over 4, and plus 3 over 2 minus 2. Putting this all together in fourths, I get negative 3/4 plus 6/4 minus 8/4. Negative 3 plus 6 gives me positive 3, and negative 8 gives me negative 5 over 4. So using the vertex method, or the formula method, I have 1/2 and negative 5 over 4. Plotting that, 1/2 negative 5 over 4, something like this. All right, looking at the other method, if I want to put this into standard form, then I'm going to complete the square. So h of x is equal to negative 3, factoring out the negative 3, and I have x squared plus x, leaving a space, minus 2. The x is equal to 1, so I have 1/2 squared gives me plus 1/4. On the outside, what I have to do is I have to undo what I've added on the inside. Now I've really not added at all. I've really subtracted 3/4 because of the component on the front. So what I'm going to do is add 3/4 out here. Simplifying, I get negative 3 and then x plus 1/2 and squared. And let me fix a sign here. If you look at this sign here, I factored out negative 3, which should have made this negative x. There's a correction for you. And negative 1/2 squared still gives you positive 1/4, but this factor here is minus 1/2. And then on the outside, I have negative 8 over 4 plus 3 over 4 gives me minus 5 over 4. All right, vertex-wise, when you pull this out of the actual standard form, so here is my standard form h of x, we have x minus h, so the vertex is the point hk, and x minus h, so x minus 1/2 gives me 1/2, and plus k on the end gives me negative 5 over 4 for my vertex. Either way is fine. They both get you to the same place. Other things that we need are the axis of symmetry. Once you've completed the vertex, you get this one for free, so it's x is equal to the x coordinate of the vertex, or x is equal to 1/2. Axis of symmetry, remember, is the line that if you were to fold your parabola on, it's symmetric on both sides. So here is your axis of symmetry. X is equal to 1/2. Now, intercept points are also needed. They come in pairs, or we get x and y intercepts sometimes. Now looking at this particular parabola has a vertex at 1/2 negative 5/4, and it opens down because it's negative. So I have no x-intercepts. If I were to try and use the quadratic formula to get intercepts, I'd come up with a negative number inside the square root, which also indicates none. As far as y, you get y-intercepts when x is equal to 0, and h of 0 is -2. So it's right about here. If I were to put that in a point, then I have the point 0, -2. Graphing the function, you notice I put an extra spot on the right-hand side. That's because I have some symmetry, so I can use that axis of symmetry to give me the extra point or guide point I need. Other parts, domain and range. Domain for a quadratic is all real numbers. Range is based on your vertex point. So the highest point this one achieves is -5/4, and it goes all the way from -infinity. So -infinity to -5/4. Let me try that again. -infinity to -5/4, and it's inclusive. All right, we will continue on in a few moments.